the motion of an object. That is, an object consists of different types of motions, that is uniform and non-uniform. And at the same time, in this chapter we are going to discuss the cause of the motion. How and what's the reason for the motion of an object, and what are the causes and what are the effects of motion of an object are discovered in this chapter. Let us see. Suppose let us kick a ball. It will be moved for some time and it will be stayed in the rest position, right? It is not moved continuously forever. That means here we can understand that every object attains a final position, that is the rest position. The rest position is the natural state of any object, right? Whenever we apply some force or whenever we give some effort on an object, it will be moved, right? It is get into the motion. That means when we drive a car, it will be moved from one place to another. Otherwise, it will be in a natural state, that is in rest position, right? And for example, let us take a trolley. When we move a trolley, it will be moved according to the effort what we give. That is, it will be pushed in the forward direction, right? When we pull a drawer, that is, when we pull for a table, the drawer, it is open. That is the pulling effect. And when we take a ball and when we hit it with a hockey stick, it is thrown away. That means it is moved from one place to another. That is hitting effect, right? Means we are applying different forces and different efforts like pulling, pushing, hitting or cracking or anything all, and we are making the objects to move from one place to another. For example, is a force should be needed for every object to be moved? That is my question. That means for some objects, what I have said, we are applying some force for the movement of the objects, right? But at the same time, is that effort is needed for every object in order to be moved? But it is different for different cases. For example, let us take the sun, planets, galaxy and stars and all those things. These are moved in such a way that we are not at all applying any force on them, but the centrifugal force or the attractive forces between them are making themselves moving in the space, right? And the objects in the space will not be fallen down, as we know, because they are moved in the space, right? And so we can say that some effort is put on stationary objects. See, for example, let us take this pen. This is in a stationary position. When I put some effect, that is when I push it with the help of my finger, it will be moved for some place, right? Therefore, for this we can say that when some effort is put, we can move that object. That is, some effort helps to move the objects from one place to other, and that is known as the motion state of the object. And that effort is also known as muscular effect. That is the effort of our hands or legs. Our energy is distributed, right? That energy is transferred into the form of motion. And let us take the force. The applied effort is known as none other than the force that is we are applying on the object. We cannot feel, we can feel the force, that is we cannot taste it, we cannot see the force, and we cannot justify with our naked eyes what is force. But we can say that the force is the effort applied on an object, right? And it is just the feeling or that inter-transformation of energy. Therefore, we can say that by applying the force on an object, we can change the magnitude, and at the same time the direction also can be changed for the objects. By, for example, let us take a spring, right? This is the spring, and we apply an external force on the spring will be compressed, right? It is changed, that is external forces are applied, then the spring position or the spring shape will be compressed. That means by the external force we are changing the shape of the spring and the magnitude of the spring, and later the direction will be changed as it is pulling that force, that is it will be coming to its normal position by breaking up that force, right? Then that is known as changing of its direction. It is pulled outwards, that means it is pushed away outwards by its internal forces acting on the spring. Thus we can say that a force can change the magnitude and direction of the objects. let us see the different types of forces which can be applied on the objects, that is balanced forces and unbalanced forces. Now let us take suppose an example, that is a wooden block is placed on a table and we have tied two strings, that is X and Y, on opposite sides of the wooden block, and let us suppose that we are pulling the string X, then the wooden block will be moving in the left side, and if we pull the string Y, then the wooden block will be going to be moved in right side direction, right? This is because why that the force applied on the string is on which side, then that side it will be pulled back, right? And at the same time when these both strings are applied, means both strings are pulled at the same time with equal forces, then the wooden block will be in rest position. It does not move either right side or left side. This is because the two forces acting on the wooden block are same and equal and in opposite directions. Therefore, it is nullified and the rest position of the object will not be changed. These type of forces are known as balanced forces. The balanced forces therefore defined as the forces acting on opposite directions and which are of equal effort. Then they are said to be balanced forces. Now the state of rest or the rest position of the object will not be changed because of the balanced forces. Whenever an unbalanced force acts, then the block will be changed from its rest position and it will be under the motion. Now suppose let us see that we are applying a greater force on X direction and lesser force on Y direction, then the block will tries to move in X direction, that is in left direction, because where the greater force will be acting, on which side the greater force will be acting, that side the wooden block tends to move. Therefore we can say that by the help of unbalanced forces, the rest position objects can be moved. For example, let us take a person is pedaling a bicycle, and for suppose the cycle is in rest position because the frictional forces acting on the cycle are balancing the forces on the cycle, that is they are in equal and opposite direction. Therefore, when the person tries to bicycle, that is when he is pedaling, he is exerting some effort on the cycle, right? Therefore, it tends into motion. That means the frictional forces are nullified and the greater force is applied by pedaling. Therefore, the cycle tends to in motion. When he stops pedaling, the motion of the cycle tends to be decreased. That means the speed of the cycle will be decreased. Therefore, we can say that the frictional forces will be coming into act, that they will be oppositely working together and they will be nullifying the force applied by the person, and thus it makes the cycle to be coming into rest position. And for many objects there are many opposite forces, such as for oils, the flow of oils or the flow of velocity or velocity of oils will be opposed by the viscous force, and for cycles like that there will be frictional force will be acting oppositely. For example, for a pen thrown upside, the gravitational force will be acting, therefore the objects will come into the rest position. Therefore we can say for every object to be in rest position, there is acting a force that is opposite and equal force. That names will be according to the object, that is frictional or viscous force or gravitational force. And thus we will be discussing the different types of forces. Now let us see this problem, that is we are calculating the change in momentum before firing and after firing. Now let us see that we are calculating the mass into velocity, that is into 150 meter per second, that is for a bullet, right? And for piston we will be calculating that 2 kgs into velocity. It is defined as V. We have to calculate this, or we have to find out this velocity, and we will be calculating as per the rule of change of momentum. The law of conservation of momentum says that the change in momentum before collision and after collision will be same. Therefore, we can see that the change in momentum before firing and after firing should be equal. Therefore, we will be calculating after firing change in momentum with the before firing change in momentum. That is, before change in momentum is 0 because the initial velocity of bullet and piston is 0. So, we are equating this after firing momentum with 0. So, it will be relating as 2 into, that is will be equals to 3. So, that's 0.02 into 150. plus 2 into v equals to 0. Therefore 2v equals to minus 3 and v equals to minus 3 by 2. That is equals to minus 1.5 meter per second. Right? Therefore we can say that the velocity or the recoiling velocity is minus 1.5 meter per second. That is why here we are denoting it, why we got the negative value means because this is the reaction of the action. That means when we fired, the bullet goes in forward direction, that is positive, that is known as action, and the recoiling of the bullet, that is opposite direction, that is backward, and this is known as the reaction for the action of the firing of bullet. Therefore we will be getting that in negative value, right? In this manner we will be calculating the forces exerted and the velocities and accelerations and the laws of motion of Newton are satisfied and calculated. We have seen the 3 laws of motion, that is the 3 laws of Newton's, that is first law, second law and third law, and the conservation of momentum in this chapter, and the forces affecting and what are the causes for the force